I'm going to go over the Math 3, Unit 6, Worksheet 9, Solving and Graphing Radical Equations. So we are asked in on number 1 in part A to solve algebraically. And I'm going to start that way. We have square root of x plus 1 is equal to x minus 1. And the first step is to isolate the square root, which it's already isolated. Second step, square both sides to get rid of the square root. And when we square the right side, it's x minus 1 times x minus 1. Need to distribute that. And we get x squared minus x plus 1. Because this is quadratic, we want to solve one side of the equation make one side of the equation equal to 0. So I'm going to subtract x from both sides and subtract 1 from both sides. So when I subtract x, I get negative 3x, and when I subtract 1, I get 0. So 0 is equal to x squared minus 3x. Factor out the x, and then set each factor equal to 0. So we end up with x is 0, and x minus 3 is equal to 0, which gives us x equals 3. And then don't forget to check for extraneous solutions. So if we go back to our original equation and plug in x equals 0, we get the square root of 0 plus 1 equals 0 minus 1, which is false. So x equals 0 is extraneous, throw that out. But if we check with 3, we get the square root of 3 plus 1 is equal to 3 minus 1, or the square root of 4 is equal to 2, which is true. So we keep x equals 3 as a solution. And part B asks to accurately graph the system of equations, which is from the algebraic equation in part A. So what we've done is we've taken the left side of the equation and made that f of x, and we've taken the right side of the equation and made that g of x. And these functions should cross at x equals 3, our solution that we got in part A. I'm going to first graph g of x. It's a line. The y-intercept is negative 1, the slope is 1, so I'm going to start down at negative 1 and go up 1, right 1. So this is our line g of x. Label it g of x. And then f of x, well, we have the translation that x plus 1 moves it left 1 from 0, 0, so that's our starting point at negative 1, 0. And I'll just take a table of values here. If I plug in a 0, I get the square root of 0 plus 1, which is square root of 1, or 1. So 0, 1. If I plug in a 3, I get the square root of 3 plus 1, which is the square root of 4, which is 2. So go right 1, 2, 3, up 2. And so we see that both graphs are intersecting at the point x equals 3, which is what we found algebraically. Next, let's take a look at number 3. Solving algebraically, first step is to isolate the radical, and it is already isolated. Second step is to get rid of that radical by squaring both sides. We get x plus 3 equals 4x squared. And because it's quadratic, we want to make one side of the equation equal to 0. So I'm going to do that by subtracting x and subtracting 3 from both sides of the equation. And then we try to factor. Here we're looking for two numbers whose product is negative 12. I get that from 4 times negative 3. And at the same time whose sum is negative 1. That's the coefficient of the x. So two numbers whose product is negative 12 and whose sum is 1. So that would be negative 4 and positive 3. So then we split the three terms into four terms. 4x squared minus 4x plus 3x minus 3, which is still equivalent to the equation above, because if we add the negative 4x and the 3x, we end up with the negative x. But by splitting it up into four terms, we can now factor by grouping. If you look at the left half, you could factor out a 4x, and you're left with x minus 1. The right half, we could factor out a 3, and we're left with x minus 1. And then we now have split it into two terms that both have a factor of x minus 1, so we could factor out the x minus 1, and we're left with 4x plus 3. So now we've fully factored, set each factor equal to 0, and solve. I'm running out of room here, so I'm going to move it over here. So we get x minus 1 is 0, which gives us, so if x minus 1 is 0, we get x equals 1. And the other one is 4x plus 3 is 0, so 4x is negative 3, so x is negative 3/4. We need to check to make sure these work back into our original. I'm going to check up here. So if x is 1, we get the square root of 1 plus 3 is equal to 2 times 1, or the square root of 4 is 2, which is true, so we get to keep that one. If x is negative 3/4, we get the square root of negative 3/4 plus 3 is equal to 2 times negative 3/4. Now on this one we have a square root of a number is equal to a negative number, and that's going to be false, because whenever you take the square root of a number you should get a positive answer, and so we need to throw out that second answer. So x equals 1 is our only answer. In part B, we rewrite the algebraic equation into a system of equations, and the way we do that is let's let f of x be the left side of the equation, which is square root of x plus 3, and g of x could be the right side of the equation, which is 2 times x. G of x is just a line with a y-intercept at 0 and a slope of 2, so up 2, right 1. And then f of x is a square root function translated left 3 units from 0, 0, so that's our first point. And then we can make a table and get some more points for f of x. If I plug in a 1, I get the square root of 4, which is 2. If I plug in a negative 2, I get the square root of negative 2 plus 3, or square root of 1, which is 1, so negative 2, 1. And you see that they both cross when x is 1, which is the same solution we got in part A. Next, let's take a look at number 5. So first step is to isolate that square root. We want that square root of x plus 5 by itself. We're going to add 2 to both sides of the equation. And then we're going to multiply both sides by 3 to get rid of that fraction. When you multiply the left side by 3, you get 3 over 3, which is just 1 times the square root of x plus 5. When you multiply the right side by 3, you get 12. Now that we've isolated the square root, get rid of it by squaring both sides. We get x plus 5 is 144. And lastly, subtract 5 from 144 and you get 139. Check that. So 1/3 times the square root of 139 plus 5 minus 2 is equal to 2. So 1/3 of 144, square root of 144, or 1/3 of 12, which is 4 minus 2 is equal to 2. That's true. So we get to keep our answer. Next, let's take a look at 9. 2 times f of x, so 2 times the square root of x plus 1 plus 19 is equal to 3. Subtract 19 from both sides. You get negative 16. Divide by 2, you get the square root of x plus 1 equals negative 8. Can't happen. No solution. Because a square root cannot produce a negative answer. Or at least no real solution, right? Number 13. Isolate the square root. It is isolated on the right side, so we're going to leave it that way, and then get rid of the square root by squaring both sides of the equation. When you square the left side, you get 2 squared, which is 4, times x equals 3x plus 6. Subtract 3x from both sides, and you get x equals 6. Let's check that. 2 times the square root of 6, is that equal to the square root of 3 times 6 plus 6, which is 4 times 6, and the square root of 4 is 2. So we get equality, that's true, so we get to keep our answer. Next, let's take a look at 17. Isolate the square root, so I'm going to subtract 3x, so I get negative 5 square root x is equal to negative 3x plus 2. I'm just going to multiply both sides by negative 1 to just change the signs. Get a positive 5x, 5 square root x. Positive 3x, negative 2. We could divide by 5 here, but if we do that we end up with a fraction, so I'm just going to square both sides as is, and we get 25 times x on the left hand side, and 3x minus 2 times 3x minus 2. Distribute that, we get 9x squared minus 6x minus 6x plus 4. We can combine like terms to get 9x squared minus 12x plus 4, and then make the left side equal to 0 by subtracting 25x. And when you subtract 25 from negative 12, you get negative 37x. And then we try to factor this. We're looking for two numbers whose product is 9 times 4, which is 36, and whose sum is negative 37. That would be negative 36 and negative 1. So rewrite this as 0 equals 9x squared minus 36x minus x plus 4, and then factor by grouping. We could factor 9x out of the first half and factor negative 1 out of the second half. And then both terms have the x minus 4 that we can factor out. And now it's fully factored. Then we set each factor equal to 0 and solve for x. And first one we get x equals 4. The second one we get x equals 1 over 9. Last step is to check to make sure there's no extraneous solutions. So if x equals 4, we get 3 times 4 minus 5 times the square root of 4 is 2. So that'd be 12 minus 5 times 2 is 2. or 12 minus 10 is 2. That's true. So we get to keep that one. And then we check 1/9. We get 3 times 1/9 minus 5 times the square root of 1/9 is 2. Well, that would be 3/9 minus 5 times 1/3, or 1/3 minus 5/3. That's going to be negative 4/3, which is not equal to 2. So that's false, and so we need to get rid of that 1/9 and just keep the 4.